There are, whoops, that is not what I want. Let me go and open up a different file. There are 3 methods of solving a system of equations. Probably the first method you learned to solve them was graphing. It is the least effective method of solving a system of equations because when you graph, you can't always tell exactly where that point is. I mean, sure, if it comes out to integers, it's great, but what if it's fractional? Then you kind of got to guess at where that point of intersection is. If you use substitution or elimination, those will come out with your exact answer, whatever they might be. So we're going to do 2 examples. We're going to do 2 by substitution, 2 by elimination, just so that you're refreshed on how to do them. I am a substitution person. I think the teacher that taught me how to do systems of equations did a better job of teaching substitution, so it's what I prefer to do. Some teachers really love elimination and they do a great job of teaching elimination. I'm going to tell you that so long as you know one or the other method, it's going to work for you. Today I'm going to force you to use both methods. But so long as you know one method, you're okay. Doesn't matter to me which method you use, other than today when we're going to make sure that you know how to do it both ways. Substitution, I would strongly recommend anytime you see you have a coefficient of 1. What's a coefficient? The number that's in front of the variable. So if I look at this first example, what are my coefficients in the first equation? 3 and -3. What are my coefficients in the second equation? -5 and 1. So I want to use substitution, so I'm going to use this second equation, and I'm going to solve this equation for the variable that has a coefficient of 1. If I'm going to solve this for x, how would I get rid of this -5a? I'm going to add 5a to both sides. X is now equal to 5a minus 3. And I could have written a -3 plus 5a. The order would not matter. I just have a tendency to put my variables before my constants. Once you're to this point, you're going to go back to the other equation. And wherever you see an x, what can I now put in its place? So where this x is, I'm going to substitute, hence the name substitution. 3a minus 3, I've got to put parentheses, 5a minus 3 equals a -3. I've substituted this value, 5a minus 3, in place of this x. The next thing I'm going to have to do is distribute, and you notice I've attached that negative to that 3. I've got to distribute that -3 through the parentheses. -3 times 5a, -15a. -3 times a -3, +9. I'm going to combine like terms. 3a minus 15a is -12a. Go ahead and subtract 9, getting the a by itself. And then I'm going to divide both sides by a -12. Please make sure that if you have a negative coefficient that you're dividing by that negative coefficient, and that a negative divided by a negative would make a positive. So a is equal to 1. Would I be finished? No. What haven't I found yet? X. The nice thing about using substitution is this x is already by itself. So where this a is, I can now replace it with 1. Obviously, 5 times 1 is 5. Minus 3 is 2. If I were to write this as an ordered pair, ordered pairs are written alphabetically, so this would be the ordered pair 1, 2. Does everybody remember doing this type of problem last year? Am I good? Can we go to the next example? What are my coefficients in the first equation? 2 and negative 6. What are my coefficients in the second equation? Negative 1 and negative 1. I'm still going to do this using substitution, and I'm going to pick one of these two variables. It really doesn't matter which one. I'm going to pick this negative y. And I'm going to solve it for this negative y. How would I get a negative y by itself? If I want to get the negative y by itself, I'm going to add what? I'm going to add z to both sides. I could have added y just as well. I now have a negative y equals z minus 1. But I don't want a negative y. What type of y do I want? How would I get rid of the negative that's in front of it? I could multiply it by a negative 1 or divide it by a negative 1. It doesn't matter. But remember, whatever I do to this side, I have to do to each thing on the other side. So this negative 1 is actually going to get distributed through. A negative times a negative made a positive. A negative times a positive is going to make a negative z. A negative 1 times a negative 1 is going to make a positive 1. Now I've got y by itself. I'm going to go to the first equation that I hadn't done anything with yet. And now in place of this y, what am I going to put there? So I have 2 parentheses, negative z plus 1 minus 6z equals negative 30. What do I have to do with that 2? It has to be distributed through the parentheses. Negative 2z plus 2 minus 6z equals negative 30. Combine like terms. Negative 8z plus 2 equals negative 30. Getting z by itself, subtract 2. Negative 8z is equal to a negative 32. Again, if you have a negative coefficient, make sure you're dividing by that negative. A negative divided by a negative is going to make a positive. Z is equal to 4. And I'm going to come back up to my y equals equation, and I'm going to substitute 4 in for that z. What is a negative 4 plus 1? Negative 3. Again, if I were to put these in an ordered pair, they'd be listed alphabetically, so this would be the ordered pair negative 3, 4. Questions on the substitution method? Now we're going to talk about the elimination method. And I think probably what made elimination harder for me to understand is it seemed to me that the teacher that I had just seemed to randomly kind of pick numbers to manipulate the two equations. I don't think he ever did a great job of explaining how it worked or why he did what he did. But I'm going to tell you that this one is easy. Why? The first coefficients, one's a negative 3 and the second one is a positive 3. So it's easy to get rid of this one. The second one that we're going to do, there's more than one way to approach it. But I'm going to tell you that if I'd have had a teacher that said if you'll do it this way, you never have to hunt for what to use, the method that I'm going to show you works all the time, no matter what's there. So you don't have to look for something to manipulate. You can use that method regardless of what's there. There might be an easier way, and if you see it, there's nothing wrong with that. The elimination method, the goal is to always find a way to make a pair of the variables so that they're opposite of each other so you can add them together. If they were actually the same, you have to subtract them. But I'm going to tell you the problem with subtraction is people forget if you're subtracting the first one that you're subtracting each individual part. So I recommend that you get them so that they're opposite of each other. If I add these together, what's going to happen to my v's? They're going to cancel out. They're going to be eliminated, hence the name, elimination. 3x minus 6x is a negative 3x. 12 plus a negative 21 would be a negative 9. And I would divide both sides by a negative 3. And x is going to be 3. I think the other thing that made this method hard for me is it seemed to me that the teacher never went back and explained which one of these equations to put it into. Does it matter? No. No, makes absolutely no difference. Would I have one that I would pick? Yep, I would. I'd pick the one with the smallest numbers. Going to be easier to work with. That is the only reason that I would pick this one. Is because the numbers look smaller than they are in the other equation. And where this x is, what am I going to put in its place? 3. So I have a negative 3v plus 3 times 3 equals 12. So the negative 3v plus 9 equals 12. Subtract 9 from both sides. Negative 3v equals 3. And when I divide by a negative 3, v is going to be a negative 1. Again, if I put it in an ordered pair, they're usually listed alphabetically, so it would be a negative 1, 3. Questions on this one? Am I good? Can I go to the next slide? Okay. Then this is the last example that we're going to do. Although I could manipulate this C value pretty easy to get it to go away, this is where I think that if I had a teacher that said, you can do this all the time, this will work 100% of the time, you never have to look for what the least lowest common denominator, greatest common factor is to see what would be the best way to manipulate it. If you will take the coefficient that's in front of this lead variable and put it in front of the first equation. Take the coefficient that's in front of the top equation and use its opposite down here. This will always work. You don't even have to think about it. Yes? I just got done saying that you could do that. I know that it would be easy to manipulate the 5. Okay? Certainly nothing wrong with doing that. But I'm going to tell you, if you can't see which variable to manipulate, this method will work 100% of the time. You don't have to hunt for it. That's the advantage to learning it this way. is that you no longer have to struggle with, and by the way, this one's super easy, but what if they weren't multiples of each other? What if one was 2 and one was 3? The other one was 7 and the other one was 11. And you had to hunt for which one was going to be easiest to manipulate. This method will, in fact, take care of that. You don't have to worry about it. What you're going to do is multiply everything in the entire equation then by that 4. So when I do that, it leaves me a negative 20a. It leaves me a positive 4c. And it leaves me a negative 120. Make sure that every individual piece on both sides of the equation get multiplied by that. I'm going to do the same thing on the other equation. 5 times 4a is 20a. 5 times the negative 5c, negative 25c. 5 times 24, 120. You'll notice that by doing this coefficient from the bottom and the opposite coefficient from the top, that I ended up with opposite coefficients at the beginning. So I'll always be able to add them. My a's are going to cancel out. I'm going to have a negative 21c is equal to 0. There were several people, even on the re-quiz for algebra, that wrote, there was no solution for this. Still, you can solve it. C isn't by itself. Divide by negative 21. And 0 divided by a negative 21 is what? 0. There is nothing wrong with having 0 as an answer. Nothing wrong with it. I can go back to either equation. It does not matter. I'm going to replace, in the second equation, I'm going to replace c with 0. The nice thing about it being 0 is it just kind of drops out when you multiply. And so all I'd have left to do is divide. So if I put this as an ordered pair, this would be the ordered pair 6, 0. Questions on elimination?